Fun Sock Friday, the 13th of November. Okay, this is actually changed to what our lesson was on Wednesday. Soon we'll be able to apply properties of systems to real-world scenarios. Okay, Wednesday we took an extra day to do it on 5.3. Okay, so you guys can understand elimination a little bit better. Hopefully that helped you guys out quite a bit. Okay, so today we are applying properties of systems to real-world scenarios. Okay, section 5.4. So basically, this is meaning word problems. Okay, this basically means word problems. Okay, so the first three sections, section 1, section 2, section 3, we learned how to solve these systems equations by these different methods. Okay, so now we're going to learn how to set up a word problem for them and to continue going from there. Jenna is deciding between two cell phone plans. The first plan has a $50 sign-up fee and costs $70 per month. The second plan has a $30 sign-up fee, costs $80 per month. After how many months will the total cost be the same? And what will this cost be? So, how many equations have we been using this whole chapter per problem? How many equations have we been doing per problem? 2. How many equations do you think we're probably going to make? 2. Okay, so what's a good first thing we always do for word problems? Maddie? Underline key information. Okay, does anyone have a piece of information they think is key information? Maddie? All the numbers. $50 sign-up fee, $75 per month, $30 sign-up fee, $80 per month.
We need 2 cell phone plans.
Oh, and 2 cell phone plans, okay? Anyone else have any key information for us? Okay, Abby. Okay, the per month. Okay, so 80 per month, 75 per month. Okay, and also have any key information? Okay, what will the cost be? That's our final question, right? And is there another question we're asking? After how many months? So really, how many months until they're the same? Okay, how many months for cost to be the same? So we have 2 cell phone plans. So we're going to do one equation per cell phone plan. Okay, we're going to do one equation per cell phone plan. Okay, Aiden, that's enough staples, buddy. Okay. The first plan has a $50 sign-up fee and costs $75 per month. Does anyone know how we could write that out? $50 sign-up fee and $75 per month. What?
I did 2x plus 50y equals 75.
Okay. Not quite, but I love that you're trying for it, okay? Not quite, unfortunately, okay? Anyone else have any ideas? Okay. Well, let's think about it this way. We have a $50 sign-up fee, right? How many times are you going to have to pay a sign-up fee? Once, right? You're not going to have to pay it again. Okay? Now, what would we do with the sign-up fee? Is that adding to the cost, subtracting from the cost, multiplying, or dividing? It's adding to your cost. And what's the other cost for a cell phone plan?
75.
It's $50 sign-up fee and $75 how often? Per month. So is it a one-time fee of $75? No. So it's not just going to be $75. It's going to be $75 each month. So we need a variable with that. What variable do you guys want to use for month? M, cool. So 50 plus 75, M. Okay, we have 50 plus 75, M so far. The $50 sign-up fee plus 75 per month equals the total cost, right? What do you guys want to call the total cost? Okay, Y? Cool, you could. Any variable would have worked. So that's my first equation. $50 for the sign-up fee, $75 per month is equal to the total cost. Any question on how we got that first equation? Can I get anyone to volunteer or at least try to do the second equation? Raise your hand if you want to try to do the second equation. Olivia?
It would be 30
plus 80 equals x.
Okay, great question. So 30 plus 80M. So far, I agree with all of that. 30 for the sign-up fee, one-time fee, plus 80 per month. 80 times however many months there are M
Oh, so
equals. Now, what do we want the cost to be? Do we want the cost to be different or the same?
the cost would be like mostly different. Well,
Okay. Well, the cost would be different depending on the number of months, right? But our first question we're asking, after how many months will the total cost be the?
Why? Wait, no.
Will the total cost be the same?
Yeah.
So, if we want the total cost to be the same, and we call the first cost y, what are we going to call the second cost?
Why?
Y, because we want it to be the same. Okay, our goal is to make these the same. Any questions on how we got our second equation? Is it pretty similar to how we did the first one?
Yeah.
Yes. Now, do we have a system of two equations?
Yes. Wait, no.
Yeah, we have two equations that go together. Now, we've learned three different methods on how to solve these. We've solved them by graphing, we've solved them by substituting, and we solved them by elimination. You have a choice here to solve them by whatever method you want. Now, does it make sense to solve these by graphing right now?
No.
Why not?
Because we don't have a graph.
You don't have a graph. Okay, that might be a pretty easy answer for us. We don't have a graph. Okay, could we solve this one by substitution? What did we need when we solved by substitution? What did we have to have? Okay, an x and a y, and we had to have a variable what? Variable by itself. Do we have a variable by itself? Yeah, could we do substitution if we wanted?
Yeah.
Okay, what do we need for elimination? For elimination, what do we need? Okay, everything lined up, and we need it. Do we have everything lined up right now in the same order?
Yeah.
Okay, so it's kind of set up for both substitution and elimination. Okay, now if we were to do elimination, would we have to get the y's to be different signs maybe?
Yeah.
Okay, so do you guys want to do elimination or do you guys want to do substitution?
Substitution.
Raise your hand for substitution. Hands down. Raise your hand for elimination.
I don't care.
Okay, substitution barely won. So what we're going to do is we're saying y is equal to 50 plus 75m. It's the same thing as it. So we're going to take the second equation, 30 plus 80m equals, instead of y, we're going to plug in this 50 plus 75m. You guys remember doing that before?
Yeah.
Okay, not really.
Yeah.
Oh man, we did this in 5.2.
I remember it.
Okay, we plug everything in from the first equation into the y of the second equation. Now, is this an equation we can solve?
Yeah.
Yeah. Okay, what do we want to do first?
Ugh.
Okay, we want to get something together. What do we want to get together? Okay, the variables. Would you rather move the 80m or the 75m? 75m? So subtract the 75m to move it across. So 30 stays the same. What's 80m plus or 80m minus 75m? 5m equals 50, and 75m minus 75m is 0. Now I'm going to put this over here to the other side because I'm running out of room. I'm just going to rewrite it. 30 plus 5m equals 50. I didn't change anything. I just rewrote it because I'm running out of room. Now what do I do to solve this?
Subtract 30.
Subtract 30. Get all those away from the variables now. 30 minus 30 is 0. What is 50 minus 30? 20. Now what do we do with this equation?
5 by 5.
Divide by 5.
M equals 4.
And m is 4. So, what did m represent? Which variable? What did it represent? Excuse me. M represented the number of months. So after how many months will the cost be the same? 4 months. So we answered one of the questions. What's the other question it's asking us?
What will the cost be?
What will the cost be? So what do we have to do with this for?
Plug it in.
Plug it in so we can find the cost. Where do you guys want to plug it in? 30 plus 80? Okay, you can plug it in top or bottom, doesn't matter. Would we rather multiply with 4 times 80 or 4 times 75? 4 times 80, it has a 0 at the end. Okay, let's do that one. We could choose. So we could have, in the blue here, 30 plus 80 times 4 equals y. What is 4 times 8? 32, add a 0 then, 320. 30 plus 320 equals y. What's 30 plus 320?
350.
350. So after how many months will they be the same, we said? 4 months. And what will the total cost be after 4 months? $350. Very good. So here's our answer. 4 months, $350. Are we doing an ordered pair this time? No. Does anyone know why not? Because that's not what it asked us. It didn't ask us for the coordinate. It asked us for answers to very specific questions. It said, how many months? What's the cost? So we answered 4 months, $350. Does that make sense?
Yes.
Now, you guys, we could have solved this problem by elimination as well, okay? Don't write this part down, but I'll show you real quick. Aiden? Aiden, do you have all this written down?
Yeah, I was just
Okay, awesome. So if we were to do this by elimination, we'd have 50 plus 75m equals y. 30 plus 80m equals y. And we'd say, okay, well, we have to change some of the equations here. So we have to make one of them negative. So let's make this top one negative. Negative 50 minus 75m equals negative y. Bottom equation can stay the same. 30 plus 80m equals y. Now we can add these equations together. Get negative 20 plus 5m equals 0. Well, I could add that 20 to move the 20 across. 5m equals 20. Divided by 5. Does m still equal 4? So did we get the same answer either way? Okay. Hey, students. Do we get the same answer either way of m being 4? Yeah. So it doesn't matter whether we do substitution or elimination.
No.
No, okay? It's your preference. So if you prefer to solve this one by substitution, then do it. If you prefer to solve it by elimination, do it, okay? You have to go back in and finish the problem, but that's good enough to show that we get the same thing. Any questions on number 1? Okay. Let's look at example 2. One cable TV provider has a $60 setup fee and costs $80 per month. The second has a $160 equipment fee and costs $70 per month. In how many months will the cost be the same, and what will that cost be? What's a good first step every time?
Underlining.
Underline information. Tobin, you have some key information for us?
Yeah.
What do you think?
All the numbers and then per month.
Okay, $60 setup fee, $80 per month. $160 equipment fee, $70 per month. Okay. Anyone else have any key information? Okay, Tobin.
What will the cost be?
Okay. What will the cost be? Okay. That's one of the questions asking us. And then we wanted to know how many months will it take for the cost to be the same? How many months will it take for the cost to be the same? Is this pretty similar to number 1?
Yeah.
Instead of cell phones, we're talking about cable, though, right?
Yeah.
Basically the only difference. Okay? Raise your hand if you can help me write down the equation here. Okay? Lainey, I want you to help me with the first one.
60 plus 80m
Okay?
equals y.
60 plus 80m equals y. $60 setup fee plus $8 for every single month equals our total cost. Now, do we have to call our variables m and y?
No.
No, you can literally pick whatever you want. Okay? Just make sure you keep it straight. Okay? Tucker, do you want to help me with the second equation?
Yep. We're at 160 plus 70m equals y.
Yeah, 160 plus 70M equals Y. I agree. $160 for the equipment fee, $70 per month, and it's going to be the total cost Y. We want to know that when the total costs are the same. Okay, Aiden, please write these down. Now, that's a big difference in cost of the startup, right?
Yeah.
60 or 160, that's huge. But on one, you pay $10 a month more, right?
Yeah.
So we're going to figure out when the costs are the same. Now, up front, would the bottom one cost more or the first one cost more right away?
Bottom.
The bottom one would cost more right away, right? Because you're putting in $100 extra right away. But let's see when the costs be the same, okay? When will the costs will be the same? So, is this one set up for... Would we be able to graph this system very well? Probably not, because we don't have a graph. Okay? Is it set up for substitution?
Yeah.
Yeah, how do we know? We have a variable by itself. Is this set up for elimination?
Yeah.
Yeah, how do we know? Everything's lined up, right? And we could just change one equation to a negative. We'd get rid of the y's. Okay? Raise your hand if you want to do this one by elimination. Raise your hand if you want to do substitution. Okay, we're doing substitution. So, 60 plus 80m equals y, meaning it's the same thing as it. So we're going to take that and plug it in for y in the other equation, okay? So, 160 plus 70m equals 60 plus 80m. Questions on how we got that? Okay, now we want to do what? Subtract 70m. Let's get our m's together. Very good, Lainey. 70m minus itself is 0. 160 equals 60. What's 80 minus 70? 10. Plus 10m. Once again, I'm running out of room, so I'm just going to go up here. Now what do we do? Subtract 60. Let's move that away from the 10m. What's 160 minus 60? 100. 100 equals 10m. Now what? Divide by 10. 100 divided by 10 is 10. So 10 equals m. So what's that mean? 10 months. Okay, so it'll take 10 months for the cost to be the same. Questions on how we got this far? Okay, what do we do now? Plug it in so we can figure out the cost, right?
Yeah.
Which equation would you rather plug into?
60 plus 80m.
Okay, the top one. 60 plus 80 times 10. I'd probably pick the top one too. Equals y. What's 80 times 10? 800. Add a 0 to it. 800. We like multiplying by 10. 60 plus 800 equals y. 860. So now we have to go back and answer our two questions. In how many months will the cost be the same? 10 months. What will that cost be? $860. So that means if you're using cable for less than 10 months, it'd be smarter for you to choose the top option. But if you're going to use more than 10 months, it's going to be cheaper to use the bottom option because you pay less per month. So after 10 months, it makes more sense to use the bottom one with the bigger upfront cost if you can afford it. Okay, that makes sense? Okay, so a lot of times, depending on how much you use, okay, the more upfront cost can be worth it. Like, let's think about it this way, okay? When you go to the store and you buy a bag of chips, what costs more? The big bag of chips or the small bag of chips?
Small bag.
The big one costs more at first, right? But you get more in the big one, right?
Yeah.
So you guys see out maybe at some stores, okay, they say how much it is per ounce. You guys ever see that?
Yeah.
How much something costs per ounce. Okay, I know Walmart says it a lot. Okay, on the tags it'll say it costs this much per ounce, okay? And if you look at the difference between the items, the bigger the item, typically, not always, but the bigger the item, almost always, is a cheaper per ounce cost. So even though it costs more for a bigger size, you usually end up getting more for your money. Does that make sense? Okay.
Matt.
Mr. Cost teaching you how to shop.
Thank you, Mr. Costa.
You're welcome, buddy. What?
I said I have to do that.
Good. All right. This is going to be a slightly different one, which is why we're going to use a table here as we see to help set it up. Sam, he spent $24.75 to buy 12 flowers for his mother. How nice is Sam?
So nice.
The boat what?
It's a gentleman.
He's a gentleman. The
It's a
bouquet contained roses and daisies. Roses are $2.50 each. Daisies are $1.75 each. How many of each flower did Sam buy? Okay, well, what are some important things for us to underline? Okay, Tucker.
The cost of each flower.
Cost of each flower. Okay, so the roses, $2.50 each. Daisies, $1.75 each. Okay, what else is important? Okay, Tobin.
How many of each type
Okay.
of flower?
How many of each type? Okay, that's good to know. How many of each type did he buy?
Spent 24 cents.
Okay, he spent a total of $24.75, right?
But 12 flowers.
And to buy 12 flowers. So we got 12 flowers. Okay? I think this is probably all the important information we need. Okay? So, it says write a system, use what for the number of roses? R. Does that make sense? R for roses?
Yeah.
Okay, what's it say to use for daisies?
D.
D. Does that make sense too?
Yeah.
Okay, so sometimes using a variable that goes along with it, like months, M, roses, R, daisies, D, can help us keep straight what variables are what. So, do we know how many roses he bought?
Uh,
No. So what are we calling it?
R.
R. So in the table for number of flowers and roses, we're going to put R. Okay, well, how much does the rose cost? Each rose cost? $2.50. Now it's per one, right? So the cost of the flowers would be 2.50 times R. Does that make sense why it'd be 250 R?
Yeah.
Okay? Because if it's just 250, I'd be like, oh, I get however many of my roses I want for $2.50. But you pay $2.50 for each rose. Okay, well, number of flowers for the daisies. What am I going to put in that box? D, because we don't know the number yet. Okay, well, what's the cost per daisy? 1.75. We're going to put D because it's per flower for every daisy. Now, what is the total number of flowers he bought?
12.
12. We know that. What's the total he spent? $24.75. We know that. Wow, rude. We don't know that. Okay, we do know that. $24.75. Now, if we look at this, let's look at the top row. With the number of roses and the number of daisies, could those get to 12?
Yeah.
Yeah, what would they have to do to get to 12? What would you do with the number of roses and the number of daisies to get the total number of flowers he bought?
We don't add.
Add them. If I add these two, it'll equal 12. That's my first equation. R plus D, and I encourage you to space it out like I did, equals 12. R plus D equals 12. That's my first equation. The number of roses plus the number of daisies is equal to 12. Does that make sense to you guys or no?
Yes.
Okay. Does anyone have an idea what my other equation might be?
250R.
250R plus 175D equals 2475. Now, is it okay that I called it 2.5 instead of 2.50?
Yeah.
Okay, that won't change anything, will it?
No.
No, because the 0 is after the decimal. Okay? So we have R plus D equals 12 and 2.5R plus 1.75D equals 2475. Okay? So, we have a couple different ways we could solve these equations, right?
Yeah.
Would this one be very good for graphing?
No.
Why not?
Because we don't have a graph.
No graph, okay? What about substitution?
Yeah.
Okay? What would we need for substitution?
Oh, never mind. No.
What do we need for substitution?
A variable to be by itself.
Variable by itself. Could we get a variable by itself?
Yes.
Yeah, but we'd have to do some work to get it there, right?
Yeah.
Okay? Is this one set up for elimination?
No.
Okay, yes and no. It's lined up, isn't it?
Yeah.
Okay, but if we add right now, we're going to eliminate something.
No.
No, okay. So it's not really set up for...
Anything.
it's like halfway set up for substitution, kind of halfway set up for elimination, right?
Yeah.
Okay. Which one do you guys want to do? Think about it. Which one would you guys rather do? You guys have your choice. Which one would you rather do?
Substitute.
I don't know.
Okay, raise your hand for substitution. Raise your hand for elimination. All right, let's do elimination. Okay, so we need to get one variable looking like another. Can we make 1 look like 2.5?
No.
We can't?
Yeah, we can.
What would we have to multiply by?
2.5.
2.5. Could we make 1 look like 1.75?
Yeah.
What would we have to do?
1.5.
Multiply by 1.75. What would you guys rather do? Multiply by 2.5 or 1.75?
2.5.
Probably 2.5. It's slightly bigger, but it's also less decimals, right?
Yeah.
Okay. Now, does it have to be a positive or a negative 2.5?
Negative.
Negatives, they have to be different signs. So let's multiply the top equation by negative 2.5. And the bottom equation can just stay the same. Well, what's negative 2.5 times r?
Negative 2.5.
Negative 2.5 r. What's negative 2.5 times d?
Negative 2.5.
Negative 2.5 d. Now, do we know negative 2.5 times 12 off the top of our head?
No.
No, let's write that down. Okay. So down here on the bottom left, I'll do it real quick. 2.5 times 12. Well, what is 2 times 5? We ignore the decimal for a moment. What's 2 times 5? 10. 2 times 2? Plus 1? 5. What's 1 times 5? 5, I put my placeholder 0. What's 1 times 2? 2. Add these together. 0 plus 5 plus 5, that's 10. 300. How many numbers did I have behind the decimal to start?
1.
1. So how many numbers do I need behind the decimal at the end?
2.
1. So it is 30. So equals negative 30. And the bottom equation stays the same. 2.5r plus 1.75d equals 2475. Now we add these together. What is negative 2.5r plus 2.5r? 0. Negative 2.5d plus 1.75d. Let's think about it this way. Are they different signs or same signs? So we're going to subtract because they're different. 250 minus 175. Let's say you have $2.50 and you go buy something from the concession stand for $1.75. They say, hey, it costs $1.75. You give them $2.50. They give you what back as change? The 75 cents. Okay? The item is $1.75 at the concession stand. Okay? You gave them $2.50. They give you 75 cents back. 0.75. 0.75 if you prefer. And it's negative, though, because the negative number is bigger. Concession stand math. Turn this into concession stand math, okay? Talk about what we do at concession stand. Negative 30 and 24.75. Different or same signs? Different. So we subtract. Okay? 24.75. Your total at Hy-Vee is $24.75. You hand them $30. How much do they give you back? Not quite. Not quite. Close. 5.25. If they give you back 6.25, they're probably getting in trouble. Laney, if you give them back 6.25, you're probably getting in trouble.
Yeah, but they told me, but say what it says on
I want you to, like, when you're, like, checking, okay, to try to do some of the math in your head.
No.
Yeah.
I tried doing that and it slows me down.
So, negative 0.75d equals negative 5.25. Could you always do this off to the side as well, guys?
Yeah.
Okay, you totally could. Okay, you can write it off to the side. There's nothing wrong with doing 30 minus 24.75, putting in the decimal, saying, oh, I got to carry a 2, make this a 10, make this a 9, make this a 10, make this a 9, and make this a 10. 10 minus 5 is 5, 9 minus 7 is 2, decimal, 9 minus 4 is 5, 2 minus 2 is 0. Oh, 5.25. There's nothing wrong with that. Negative 0.75d is equal to negative 5.25. What would we do now? divide by negative 0.75, right? Now, you guys probably don't know this off the top of your head, and that's okay. Let's do it off to the side. What's a negative divided by negative going to be, though? Positive. So we know it's going to be positive. 5.25 divided by 0.75. What do we have to do with that decimal outside?
Move it.
Move it. 2 spots. What do we have to do with the decimal inside?
Yeah. Wait, no, you have to move it.
You have to move it the same amount. We don't normally care that there's a decimal inside, but if the decimal outside moves, the decimal inside has to move the same spots. So, we say, does 75 go into 5?
No.
Does 75 go into 52?
No.
Okay, so now we have to figure out how many times 75 goes into 525. Okay, well, the number ends in a 5, so 5 times what can end in a 5? Okay, 9, 5 times 7, 5 times 5. What kind of numbers are those? 1, 3, 5, 7. They're not. They're odd numbers.
Yeah.
Okay, 5 times an odd number will give it end in a 5. So let's try some odd numbers. What is 75 times 5? Okay, what's 5 times 5? 25, ha ha ha. What's 5 times 7? 35 plus 2?
45.
37. Okay, so it's not 20, it's not 75 times 5. What about 75 times 7? Let's try the next odd. 7 times 5? 7 times 7? 49 plus 3? 52. What do we notice? We have our answer.
525.
So did using that little 7 or using that little trick of we want the 5 to look like a 5, does that help us trim down our guesses?
Yeah.
Yeah, it helps you speed it up. Okay. Makes your work easier. So D is equal to 7. So how many daisies did Sam buy?
7.
7. He bought 7 daisies. So how do we figure out how many roses he bought? Because we want how many of each flower.
Well, I mean, if you're smart, you could just do 12 minus 7.
Okay. Why can we do that?
Because it already gives us what... We already got how many daisies he has.
Yeah. So really, you're plugging into the top equation, r plus 7 equals 12, without even thinking about it. Because we subtract 7, r is 5. So how many roses did he buy?
5.
5 roses. How many daisies did he buy?
7.
7 daisies. And that's your answer. Okay, that's your answer. Questions on that? Alrighty. I want you guys to put these away but get your foldables out.
I foldable.